Charon should have been dead. 5.9 billion kilometers from the Sun, airless, frozen to 220 degrees below zero, orbiting a world that had already been demoted to a footnote. Nobody was watching it closely. Nobody thought they needed to. When New Horizons flew through the Pluto system in July 2015, Charon was a secondary target, something to photograph on the way past. The spacecraft looked. It recorded. It moved on. And for 9 years, the scientific consensus treated Charon as a solved object, a cold, inert, chemically simple moon with one strange feature and no remaining questions worth urgency. That assumption held until James Webb looked at the same object with different eyes and found something that should have been there all along. The story of Charon begins with an accident. In 1978, astronomer James Christie was examining photographic plates of Pluto at the U.S. Naval Observatory when he noticed something wrong with the image. Pluto appeared elongated, not perfectly round. He looked again. The elongation was real, and it was moving. What he had found was not a distortion in the optics. It was a moon, one so close to Pluto, and so large relative to it, that the two objects were almost blurring together at that distance. They named the new moon Charon, the ferryman of the dead. In Greek mythology, Charon was the figure who carried souls across the river Styx into the underworld, into Pluto's domain. The name seemed appropriate for something dark, cold, and distant. What no one predicted was that the name would turn out to be more literally accurate than intended. Charon, it would later emerge, really does carry things toward Pluto. Or rather, Pluto takes things from Charon and gives things back. The exchange has been running for 4 billion years. Nobody thought to measure it carefully until recently. For most of the decades after its discovery, Charon remained a blur. Even Hubble could only resolve it as a separate point of light from Pluto in the late 1980s and 1990s. Its size became clearer, roughly 1,207 kilometers across, about half the diameter of Pluto, making it the largest moon in the solar system relative to its host body. By the early 2000s, scientists had detected water ice on its surface, ammonia-bearing compounds, a dark, grayish tone overall. Nothing that suggested activity, nothing that demanded urgency. Pluto was the interesting object. Charon was the footnote to the footnote. Then New Horizons arrived. The flyby on July 14, 2015 changed Charon from a pixel into a world. The images showed a surface carved by ancient geological forces, enormous canyons running thousands of kilometers, smooth plains, craters surrounded by bright ejected material, rich in crystalline water ice and ammonia compounds. The surface was stranger than anyone had predicted. But one feature stopped scientists cold before they had finished processing the first images. The North Pole of Charon was red, not slightly reddish, not faintly tinted, a deep, dark, rust-colored cap stretching across the polar region in a formation scientists immediately nicknamed Mordor Macula, after Tolkien's land of shadow and flame. It covered an area roughly the size of Texas, and it had no obvious explanation. Here is the problem. The red material is made of tholins, complex organic compounds that form when simpler molecules like methane and nitrogen are exposed to radiation from the sun or cosmic rays. On Pluto, tholins form in the atmosphere, where sunlight breaks apart methane molecules, which then recombine into heavier structures that eventually drift to the surface. That process makes sense for Pluto. Pluto has an atmosphere. Charon does not. And yet its North Pole is coated in the kind of material that should require one to form. That should have ended the mystery quickly. It did not. The explanation that eventually emerged, published by Will Grundy and colleagues in 2016 using New Horizons data, was stranger than expected, and yet, once stated, almost elegant. Pluto is losing its atmosphere. Methane and nitrogen bleed into space continuously. Methane at a rate of roughly 1.3 kilograms per second. Nitrogen even faster by mass, but slower by molecular escape. Some of that escaping gas travels outward. Charon orbits close, only 19,640 kilometers away, 1/20th the distance between Earth and the Moon. The Moon intercepts about 2.5% of everything Pluto sheds. During Charon's long polar winters, when the night side drops to temperatures barely above absolute zero, that intercepted methane freezes directly onto the surface. Cosmic rays and interplanetary ultraviolet light then process the frozen methane, linking molecules together into heavier organic chains. When sunlight returns, the pure methane and nitrogen ice evaporates. What remains is a dark, sticky residue. Over 1 billion years, the models suggest, roughly 30 centimeters of this material would accumulate at each pole. 30 centimeters of Pluto painted onto Charon, molecule by molecule, across geological time. That explained Mordor, or most of it. The model worked. The numbers were consistent. The 2016 paper was widely accepted. And so Charon was filed again, not as a solved object exactly, but as a sufficiently understood one. There were still questions about the South Pole, which New Horizons could only partially glimpse using light reflected off Pluto during the flyby. The reflected light, sometimes called Pluto shine, was dim enough that scientists could confirm the South Pole appeared similarly dark and reddish, but the full details remained blurred. That was noted, and the field moved on. There was a second unsolved detail that also moved on with it: carbon dioxide. Cometary science and models of the early solar system suggested that carbon dioxide should be present in the outer solar system, including on objects like Charon. Scientists looked for it. New Horizons carried a spectrometer capable of detecting it at wavelengths below 2.5 micrometers. It was not there. The instrument looked across the available spectral range and returned nothing. Carbon dioxide was absent. Researchers noted it, recorded it as unexpected, and turned their attention to the data that was present. That should have been the end of the carbon dioxide question. It was not. In 2022 and 2023, the James Webb Space Telescope turned its near-infrared spectrograph toward the Pluto-Charon system across 4 separate observing sessions, covering different viewing geometries so that the full northern hemisphere of Charon was mapped. The instrument extended the spectral range far beyond what New Horizons could access, up to 5.2 micrometers, into territory that had never been explored for this object. What it found was carbon dioxide, clear absorption bands at approximately 2.7 and 4.3 micrometers, present in all 4 observations, unmistakable, and not just present in a specific, unusual form. The carbon dioxide was crystalline, pure. It appeared as a thin veneer on the uppermost layer of the surface, sitting above a substrate of water ice, ammonia compounds, and tholin-like materials beneath. The structure was layered like geological strata. The top surface was not a uniform blend. Something had arranged it. The result, published in October 2024 in Nature Communications by a team led by Silvia Protopapa of the Southwest Research Institute, also contained a second detection that had not been anticipated. Alongside the carbon dioxide was hydrogen peroxide, on the frozen surface of an airless moon 5.9 billion kilometers from the Sun. The simple explanation for the hydrogen peroxide exists and is probably correct as far as it goes. When ultraviolet light and energetic particles from the solar wind strike a water ice surface, They break water molecules apart and can drive them back together in new configurations, including hydrogen peroxide. The process is called radiolysis. It is well documented in laboratory settings and has been observed on other icy bodies in the outer solar system. On Charon, the surface is almost entirely water ice. The radiation environment is weaker than in the inner solar system, but it is present. Solar ultraviolet, galactic cosmic rays, interplanetary Lyman alpha photons reflecting off the diffuse hydrogen cloud that fills the solar system. Given billions of years of exposure, forming hydrogen peroxide is not surprising. The radiolysis explanation handles the hydrogen peroxide. It does not handle everything. The carbon dioxide is a different problem. Radiolysis does not easily produce crystalline carbon dioxide in the quantities or the pure form detected by Webb. The team's preferred interpretation is that the carbon dioxide comes from below. Charon's interior likely contains carbon dioxide from the time of its formation, preserved in subsurface reservoirs since the early solar system. Impact events, comets and asteroids striking the surface over 4 billion years, excavate material from depth and deposit it on the surface as bright ejecta. The fresh craters visible in the New Horizons images, surrounded by those bright deposits rich in water ice and ammonia, are consistent with this process. Each impact is a window into the interior, briefly opened and then slowly closed again by surface chemistry. If that interpretation is correct, then the carbon dioxide sitting on Charon's surface is ancient, primordial. It formed before the planets were finished forming, and it has been sitting inside Charon in the dark and cold for billions of years, preserved because nothing disturbed it, and because the temperature at that depth never allowed it to migrate or sublimate away. The surface we see through Webb's instruments is not just a frozen moon. It is an archive, which raises the question that this answer cannot close. If the carbon dioxide has been locked inside since the beginning, then New Horizons in 2015 was always going to miss it. The instrument simply did not reach far enough into the infrared. That is a satisfying technical resolution. But the crystalline form of the carbon dioxide at the surface creates a separate problem. Crystalline carbon dioxide is fragile in a radiation environment. Over geological time, it should degrade, become amorphous, mix with other surface compounds. And yet, it appears as clean and structured as if it were freshly deposited. Either impacts are continuously refreshing the surface. Charon is geologically more dynamic than the inert world the models assumed, or something about the preservation environment at that location is not fully understood. The team's paper does not claim to have resolved this. The Springer Nature technical note, written by Protopapa's group after publication, explicitly states that future observations targeting spectral gaps not covered in the current data could lead to further discoveries. The South Pole remains unmapped at this resolution. The full chemical inventory is incomplete. And whatever is underneath, whatever the interior of Charon actually contains, has never been directly measured. The case is not closed. It is open in a different shape than it was before. And then there is the hydrogen peroxide, which is not simply a surface chemistry curiosity, because hydrogen peroxide has been seen before, on a different world, much closer to the Sun. And what it means there changes the shape of every question about what it means here. The other world is Europa. Jupiter's moon sits roughly 630 million kilometers from the Sun, close enough to receive real warmth, close enough to be caught in the gravitational violence of Jupiter's tidal forces, which flex and heat its interior continuously. Europa is one of the most studied candidates for extraterrestrial life in the solar system. Beneath its cracked, icy shell, a liquid ocean almost certainly exists, kept liquid by that tidal heating, insulated by the ice above. Scientists have been trying to understand how oxygen might reach that ocean for decades, because oxygen is one of the conditions that makes complex chemistry and possibly life possible. The mechanism they identified involves hydrogen peroxide. Solar radiation and charged particles from Jupiter's magnetosphere strike Europa's icy surface and drive radiolysis, the same process, in principle, that operates on Charon. Hydrogen peroxide forms at the surface. When the ice is eventually recycled downward through geological processes, the hydrogen peroxide goes with it. It breaks down in the warmer subsurface environment and releases oxygen into the ocean below. The hydrogen peroxide is not the destination. It is the delivery mechanism. Protopapa's team noted this explicitly in the 2024 paper. The detection of hydrogen peroxide on Charon was compared directly to what has been observed on Europa. The same molecule, the same radiolytic origin, the same basic process operating on a water-ice surface under radiation bombardment. The comparison was made carefully, without overreach. But it was made. Charon does not have a subsurface ocean. There is no current evidence for one. The tidal forces from Pluto are too weak to provide meaningful internal heating, and Charon is too small and too cold to retain significant radiogenic heat at this point in its history. A 2022 study from Purdue University, led by Stephanie Menton and colleagues, proposed that Charon may have had a liquid ocean in its distant past, during the earliest period of solar system formation, when radiogenic heating was more intense. That ancient ocean may have contributed to the red coloration of the poles by releasing methane that had been dissolved in the liquid interior, methane which then migrated to the surface and underwent the same radiation processing that produces tholins today. It is an intriguing hypothesis. It is not confirmed. The evidence is indirect, the modeling is preliminary, and the paper itself treats it as a possibility rather than a conclusion. What can be said with confidence is this: the mechanism that produces hydrogen peroxide on Charon is real. The molecule is there. The process that made it is understood. And that process is the same one scientists have been pointing to on Europa as a potential pathway for making an ocean habitable. The Goldilocks zone is where we look. It may not be where chemistry looks. That single observation, that the same oxidant production pathway operates on a world with no liquid water, no internal heat source, no atmosphere, no orbit around a gas giant, nearly 6 billion kilometers from the Sun, forces a quiet but significant revision. The habitability framework scientists have built assume that the right conditions cluster together in the right places, the right distance from the right star, the right geological activity, the right chemistry, all operating simultaneously in the same location. Charon is not in any of those zones. Charon is not supposed to be doing any of this. And yet, the chemistry is there, running steadily, accumulating over geological time because radiation and water ice and 4 billion years are sufficient ingredients for a process that only looks exotic when it appears somewhere unexpected. This is the part of the story that does not fit easily into the original frame. The discovery was reported as a detection of CO2 and H2O2 on a distant moon. That is accurate, but the implication underneath it is larger. If this chemistry operates on Charon, then it almost certainly operates on Eris, on Makemake, on Sedna, on the hundreds of similarly composed trans-Neptunian objects scattered through the outer solar system, objects that have never been visited by a spacecraft, objects that have barely been resolved as disks by any telescope, objects that we have been treating as inert debris from the formation of the solar system. The 2024 Webb observations of Charon were partly designed as a reference case, a well-characterized object against which other Kuiper belt bodies can be compared. The team stated explicitly that future JWST observations of trans-Neptunian objects will use this data as a baseline. In other words, Charon is not the anomaly. Charon may be the template. Consider what that means. The outer solar system, cold, dark, seemingly dead, populated by billions of small icy bodies drifting in long orbits far from any star, may have been running surface chemistry continuously for 4 billion years. Not chemistry that produces life, not chemistry that suggests anything biological is happening now, but chemistry that produces the oxidants, the organic compounds, the molecular precursors that would be necessary if those conditions ever changed. The outer solar system may be a slow archive, storing the raw materials for processes it cannot yet complete, waiting for conditions that may or may not arrive. The universe doesn't need us to observe it to exist. We are the newcomers. That idea is uncomfortable, not because it implies danger, but because it implies scale. The chemical processes running on Charon were not waiting for us to discover them. They were not performing for the New Horizons cameras. They were not paused between 2015 and 2022 while we processed the flyby data and concluded the object was understood. Charon was doing what Charon does. The surface was layering. The impacts were excavating. The radiation was processing. The tholins were accumulating slowly at approximately 30 centimeters per billion years, decade after decade, century after century, without interruption. We sent one spacecraft past it at high speed and declared the case complete. We were wrong, not because anyone made a mistake, but because the tools we brought were not sufficient for the object we were examining. New Horizons was a triumph of engineering and mission planning. Its instruments answered every question they were designed to answer. The questions they could not answer were not on the list, not because anyone omitted them deliberately, but because no one knew to ask them yet. That is a different kind of gap than ignorance. It is the gap between what a generation of scientists can see and what the universe contains. If you were standing on Charon's surface, and standing is the wrong word, because the gravity is so weak you would need to move carefully to avoid drifting off, you would be in a place where the sun appears as a bright star, not a disk. The sky would be essentially black at noon. Pluto would hang large and close, about 8 times the angular diameter of the Moon as seen from Earth, its surface marked with the pale, heart-shaped nitrogen plain and the dark equatorial bands that New Horizons made famous. The ground beneath your boots would be water ice, old and hard. The temperature would be far below anything measured naturally on Earth. And somewhere beneath you, in the interior of this moon, that nobody considered worth urgency for most of the decades since its discovery, there would be material that formed before Earth had continents. Carbon dioxide locked into crystal structures, preserved intact, waiting for an impact to bring it to the surface where a telescope 4 billion kilometers away could finally detect it. That is not a metaphor. That is the public record as of October 2024. The South Pole of Charon has not been fully examined at the resolution that Webb brought to the North. The spectral gaps in the current data mean the chemical inventory is still incomplete. Protopapa's team has stated directly that future observations may reveal additional compounds and mechanisms not yet identified. The archive is not fully read. We have seen 4 geometries of one hemisphere and drawn the first careful conclusions from them. The picture is better than it was. It is not finished. Mordor Macula is still there. The dark red cap at the North Pole of Charon, Texas-sized, building slowly from the molecules Pluto sheds into space and Charon catches and keeps, It is still accumulating. The process has not paused. Whatever Pluto is losing right now, at this moment, 1.3 kilograms of methane per second bleeding into the cold, some fraction of it will find Charon's surface, freeze, sit through the polar winter, absorb radiation, and add another invisible layer to a feature that has been growing since before Earth had multicellular life. We named the ferryman after an ancient function we thought was purely mythological. It turns out Charon has been carrying things all along, quietly, in the dark, without anyone watching closely enough to notice. Charon should have been dead. It was not. And the part that lingers is not the chemistry, or the carbon dioxide, or even the hydrogen peroxide and what it echoes. The part that lingers is the 9 years between one look and the next, and the question of how many objects we have already filed as understood, already moved past at high speed, already removed from the list of things worth urgency that are out there right now, doing something we have not yet thought to measure.